Today we will discuss some of the examples, some examples which are already given in your textbook, and we will discuss some few more extra examples also, relevant examples જે તમારા ટેક્સ્ટબુકમાં આપેલા છે એના જેવા જ અમુક એક્સ્ટ્રા એક્ઝામ્પલ્સ પણ આપણે ડિસ્કસ કરશું. ચલો લેટ્સ સી. NCERT solved example 1.3 is given. I've written the question and solution for you. How much positive and negative charge is there in a cup of water? Question is clearly given to you. In a cup of water, how much positive and negative charge is there? Initially, we'll assume that in this sum, a cup of water, it has a capacity of 250 centimeter cube. See, 250 centimeter cube, so mass of the water, it becomes 250 gram. 250 gram, 250 ml cube, 250 centimeter cube, its weight, mass would be 250 gram. Molecular weight of water, its formula is H2O, 2 hydrogens, 1 oxygen. For hydrogen molecular mass is 1, oxygen is 16, 2 plus 16, it becomes 18. Molecular mass of water is 18 gram. So number of molecules available in the 1 mole. 1 mole means 18 gram of water, Avogadro number, that is 6.023 into 10 raised to 23 atoms. That is the 1 mole of an atom. So in 1 mole of H2O, which has a mass of 18 grams, the number of atoms available are 6.023 into 10 raised to 23 atoms are available already. So in a cup of water of 250 grams, how many number of atoms would be available? Cross multiply. Let's cross multiply. 250 into 6.023 into 10 raised to 23 n into 18. So this is the number of molecules available. This is the number of molecules available in 250 grams of water. Come over here. Each molecule of water contains 10 electrons. How come 10 electrons? Let's see. 2 electrons from hydrogen and 8 of oxygen. So total it becomes 10 electrons are available. So total number of electrons 10 into this entire number which was already there with us. 10 is the number of electrons into entire number. So n becomes 8.365 into 10 raised to 25. Fine. So total charge. For in quantization topic, we've seen that Q is equal to NE, number, into E. It's simple. Number of charge into E. The number of charges available is 8.365 into 10 raised to 25 into 1.6 10 raised to power minus 19. So we get the charge. This calculation you have to perform by yourself, students. Next example will be seeing extra example for Coulombs law. Question is there in front of you. I'll explain the question also. A free pitch ball naming P. Name of the pitch ball is P of 10 grams. Mass is given 10 grams. Carries a positive charge. Value is given to us 5 into 10 raised to minus 8 coulomb. What must be the nature and the magnitude of other charge so that it should be given another pitch ball? We have another pitch ball of Q which is kept at a distance of 7 centimeter below the previous ball, so that the upper ball is stationary. Let's see the figure. Pitch ball P is there. It has a charge Q1. Another pitch ball is there. It's of naming Q, charge is Q2. We need to find this Q2. Q1 is already given to us. Mass of this pitch ball we already have with us. The gravitation force, downward gravitation force of P, that would be mg, and the electrical force by Q on P, this would be in the upper direction, this gravitational force would be in the downward direction. The instant, the moment when electrical force and gravitational force both would be same, these both forces will balance each other. Let's see. We'll be writing the initial, we have written the given data for you. Mass 10 grams means 10 raised to minus 2 kg. Charge is given. Distance, separation, R is given to us already. It is given. So when the balls are stationary, my gravitational force and electrostatic force will be equal. Gravitational force is mg, while electrostatic force is k q1 q2 upon r square. We need to find q2, so we made a q2 as the subject of the equation. q2, which is equal to mg r square upon k q1. Putting all the values we have with us, we get q2 is 1.067 10 raised to minus 6 Coulomb. So let's discuss some more examples. Example in front of you. Force of attraction between 2 point charges placed at a distance is given to us is D. Force of attraction between charges which are placed at a distance D is given F. Fine. What distance apart they should be kept in the same medium so that the force between them becomes 2F. Students, understand the question. In this question, two cases are given to us. In first case, distance is D, force is F. In next case, it is given to us distance between distance. They are asking us the distance to find out the distance, but the force between the charges is 2F. We'll write a case 1, F1, which is given, value is given to us F, k q1 q2 upon r square. In case 2, let the distance between two charges be r. We assume the distance is r. F2, which is 2F, k q1 q2 upon r square. We'll take the ratio, or you could directly put down the equation also. We'll put the equation 1 in equation 2. See, we'll put the value of F over here. This entire equation F I kept over here. K q1 q2 becomes cut. So what is left over with us? 2 upon d square, which is equal to 1 upon r square. Reverse the terms. D square by 2 is r square by 1. Giving the square root this side, d by root 2 is equal to r. So our r distance, new distance becomes, new r is d by root 2. Distance r becomes d by root 2. 1 by root 2 is 0.707. This is the new distance we obtained. Next example, let's see. Two charged particles are there. They are having the charge of 2 into 10 raised to minus 8 Coulomb. Charge is given to us 2 into 10 raised to minus 8 Coulomb. They are placed in such that they are joined with an insulating string. Length of the string is given to us, which is 1 meter. And the system is kept on the smooth horizontal table. We need to find out the tension in the string. See the figure. Two charges are there. Both the charges are connected with the help of a string. Distance between them is 1 meter. Given data is over here. Charges Q1, both the values are same. Q is equal to 10 raised to minus, Q is equal to 2 into 10 raised to minus 8 Coulomb. R, distance between them is 1 meter. Tension in the string. Tension is the force only. Tension is force which that you need to find. Tension T is the electric force between two charges. That is electrostatic force. So electrostatic force is K Q1 Q2 upon R square. K 9 into 10 raised to 9. Q1 Q2, both the values are same. 2 into 10 raised to minus 8 Coulomb whole square. Distance is 1. Put down the values. You need to calculate all the sum, students. So we get the answer F is equal to 3.6 into 10 raised to minus 8 Newton. Listen one thing, all the sums which I am teaching you, you will be getting the PDF notes of it in the WhatsApp group. So you need to write these sums twice in your homework notebook. So we'll be seeing next sum again. Let's see student next example, that is your NCERT example number 1.4. Very big question it is. Let's understand the question. Its example is very easy in the solution. The question is very big, but solution is easier. Coulombs law for the electrostatic force between 2-point charges and Newton's law for the gravitation force between two stationary point masses. Both have inverse square dependent on the distance. Yes, we know Coulombs law is Q1 Q2 upon R square, while the gravitation force between two stationary masses is F is equal to G m1 m2 upon R square, dependent on the distance between charges and the mass. We need to compare the strength of this force by determining the ratio of their magnitudes. Cases are there. First, for electron and a proton. Next case is for two protons. We'll discuss this question first, then we'll go to the second question. See the solution, students. For electron and a proton, electric force between two, that is electron and a proton, we will consider magnitude of force Q1 Q2 upon R square. We have considered a magnitude of force, so no minus sign is to be included over here. K upon R square. Gravitational force is G-me, mass of electron, mass of proton upon R square. We'll take the ratio of these both. C. Electric force and gravitational force, Ke square upon R square. This becomes inverted G-me upon R square cut. Ke square upon G-me. We'll put down all the values. K 9 into 10 raised to 9, E 1.6 10 raised to minus 19 whole square. Value of G we know 6.67 10 raised to minus 11. Mass of electron 9.1 10 raised to minus 31 kg. Mass of proton 1.67 10 raised to minus 27. You need to calculate all this value. You will be getting 2.3 10 raised to 39. Similarly, it is told to us next case is for two protons. In case of two protons, again we'll write electrostatic force is K upon R square. Gravitational force, students, just remember one thing, we have taken two protons, so mass of proton into mass of proton, G-mp upon R square. Take the ratio of these both, force of electron upon electrostatic force upon gravitation force. R square will be again cut. So pay attention. K square upon G-mp square. K is 9 into 10 raised to 9 into 1.6 10 raised to minus 19 whole square. Value of G 6.67 10 raised to minus 11. Mass of proton is 1.67 10 raised to minus 27 whole square. Ratio you will be getting 1.3 10 raised to power 36. First solution is over. Let's see next question. Let's come back over here. We need to estimate the acceleration of electron and a proton due to electrical force of the mutual attraction. When they are at a distance, it is clearly given to us, students, in the question. The distance is given 1 angstrom. You need to find out the acceleration when they are at a distance of 1 angstrom. Let's see, come on. The mutual attraction force between electron and proton is K, Q1 Q2 upon R square. Value of K we have 9 into 10 raised to 9. Q1 Q2, charge of electron and proton both are same. 1.6 10 raised to power minus 19 whole square, and distance is 1 angstrom. 1 angstrom, students, 1 into 10 raised to minus 10 whole square. So this force comes to us, that is 2.3 into 10 raised to power minus 8 Newton is the force with us. This is the value of force. Kindly please note it. Acceleration. There are two cases, for electron and for proton. Force, which is equal to mass into acceleration, and acceleration. So our acceleration becomes force upon mass. Force, we have the value. Already we have the value of force. Value of force is 2.3 into 10 raised to minus 8 Newton. Mass of electron 9.1 10 raised to minus 31 kg. We'll be taking the ratio of these both. We get the value of acceleration of electron 2.5 10 raised to power 22 meter per second square. While for proton, force, which is equal to mass into acceleration, acceleration of proton, which is equal to force upon mass. Force 2.3 10 raised to minus 8. Mass of proton is 1.67 10 raised to minus 27 kg. Acceleration of proton is 1.3 10 raised to power 19 meter per second square. So in today's session we have seen the 5 examples. You will be getting the notes in the WhatsApp group. You need to write all the example 2 times. Students, remember, you need to write all the example 2 times without fail, and you need to submit your homework also. Thank you.